Hi everyone, this is lesson 3 for your calculus notes, estimating limits using known functions. So you should be on pages, 13 and 14 to take notes for this lesson today. So let's take a look at our learning targets. You'll notice the first one is actually a crossover from lesson 2. So I can write a limit statement using correct notation that references a given function. So like I said, that is from lesson 2. Now this next one, I can estimate a one-sided and or two-sided limit using the graph of a known function. So this is just a little bit different than what we did in lesson 2. In lesson 2, I gave you a graph and asked you to simply find the limits. Now I'm going to just be giving you an equation, and it's an equation of something that you should know the graph of, and you'll use that graph to then estimate the limit. So let's take a look at what some of these equations look like. So you'll notice on pages 13 and 14, we have put in some graphs of equations that we think by now in your math career, you should be able to recognize without us giving them to you. So we're not going to go through all of them, but there are going to be a couple of things that I want to point out, and especially I want to talk about different transformations that we can do with these graphs. So if we think about all these graphs that we gave you, these are all the parent functions, right? They're the very basic ones, but we can do different transformations. So for example, if you take a look at y equals the absolute value of x, we know that it's this V shape, right? But we can use different transformations and move the graph. So let's say we had y equals the absolute value of x plus 2. You guys should be able to look at this and recognize that this plus 2 is a transformation. And what it's going to do is it is going to shift your graph up by 2 units. So it means you're going to take every single point that's on that graph and just move it up by 2. So instead of the vertex being at 0, 0, it's going to be at the point 0, 2, and then everything else about it is going to be exactly the same. So we're taking the exact same graph and literally just moving everything up by 2. That doesn't look like a very straight line, but hopefully you guys are with me. Let's look at this parabola also. So y equals x squared is the basic parent function, right? We're able to look at it. We've got this basic U shape. So anything that's got an x squared is going to have this basic parabola shape. But what if I gave you, oops, sorry, got to switch back to the pen. What if I gave you something like this? Y equals x minus 2 quantity squared. You should still be able to recognize that that's going to be a parabola. It's just that now there's this transformation to it. This minus 2 is going to shift your graph 2 units to the right. So instead of our vertex being at 0, 0, now our vertex is going to be at 2, 0, but everything else about our parabola stays the same. So we literally just took it and slid it over 2 units. So this is what I mean when I say you have to not only know the parent functions, but you have to know how the transformations affect those parent functions also. So again, I'm not going to go through all of them. I do want to take a second and just point out this is the graph of e to the x. This is going to be one that shows up a lot in some of our AP questions. So you're going to definitely want to make sure you know that graph. And we're going to look at an example which takes that one a little bit more in depth so that we can talk about it. On this next page here, the next thing I really want to point out to you guys is this graph in the middle. We've got y equals the square root of 1 minus x squared, and you'll notice it's this little semicircle. So I want to take just some quick notes about this really quick. I just said quick twice in one sentence, sorry. So let's take a look at this. In general, we've got y equals the square root of r squared minus x squared. If you see an equation that looks like that, then you should know automatically that this is going to be a semicircle with radius r. And since it's a positive, it's going to be that positive above the x-axis semicircle with whatever radius. So in this one, this is a semicircle with a radius of 1. Now, if it had the negative sign in front, if it was the negative square root of 1 minus x squared, that's when we would draw in this portion on the bottom. Okay, but really what I want to emphasize is you have to know that the square root of r squared minus x squared is going to give you that semicircle. Okay? You should also notice that here on page 2, we've got your basic trig functions, sine, cosine, tangent, and inverse tangent. So that means knowing your unit circle is going to be something that's really important as we go through also. So again, you've got to know these parent functions and the transformations, and knowing the unit circle will help you with your trig functions. So let's take a look at what some of these examples actually look like. So the directions say use your knowledge of parent functions and transformations to evaluate each of the limits below. Question 1 says the limit of x cubed as x approaches negative infinity. So what I want to do is I'm going to need to use my knowledge of what the graph of x cubed looks like in order to evaluate this limit. So I'm going to do a quick sketch. I know that x cubed looks like this. Well, that was a really bad sketch. Let's do that again. Sorry. That's a little bit better. Okay, so that is my basic cubic function, right? It doesn't have to be perfect. You don't have to draw out any scales or anything like that. We just need a rough idea of what's going on. So the limit is asking us to evaluate as x gets closer and closer to negative infinity. So what we're going to be looking at then is what's happening as x gets more and more negative, which means we're going that direction. And we can see then that that is also heading to negative infinity. So I can't actually plug anything in, right? I can't plug in a negative infinity. So I'm not doing that. I'm using my knowledge of the graph to figure out what this limit actually is. Okay? Let's take a look at the second one. So now we have the absolute value of x plus 2, and we're looking at the limit as x approaches 0. So let's think about this parent function. We know that this parent function is the absolute value of x, which means we're just looking at that simple v. However, this isn't the parent function. This has that plus 2 on the outside, which means we're now looking at shifting our graph up 2. So we're going to take this v and move it up like this. All right, and now we're looking at the limit as x approaches 0. Well, this is not a one-sided limit, which means we need to look from both sides of 0. So as we approach 0 from the left side, our graph is approaching 2. And as we approach 0 from the right side, our graph is also approaching 2. So this overall limit here is going to be 2 because the left side and the right side are equal to each other. All right, let's take a look at the limit of 1 over x as x approaches 0 from the left. Now, hopefully you recognize that this is the inverse function. And so our graph is going to have a vertical asymptote at 0 and a horizontal asymptote at 0. And we've got these branches, one that's in the first quadrant and one that's in, oh, that was a really bad one, sorry. One that's in the third quadrant down here. So this is what the basic inverse function looks like. Now we're looking at approaching 0 from the left, which means to the left of 0, what does it look like is happening with our graph? So the left side of 0 means we're going to be looking over here. And so we're looking at what's going on over here. And this is heading off to negative infinity. And just as a reminder, if you're not familiar with these graphs, they are shown up here for you. So our inverse function graph is right here. So this is where I just got that sketch from, if you're not sure of the graph on your own. But if you're not sure, I would suggest making like flashcards or something, because you're definitely going to need to know what these graphs look like. Cool? All right, question number 4. So we're going to look at the limit of x minus 2 squared as x approaches 2. So let's think about what this graph looks like. Well, the basic parent function is going to be x squared, which means we're going to have a parabola that's centered at 0, 0. That's our basic parent function. But we notice that there's a shift here, right? There's a transformation that's going to make this move. So this is going to shift our graph right 2. So when we look at our parabola, we're going to take everything and move it 2 units to the right. So there's my parabola. I just slid it over 2 units to the right. So now I'm looking at the limit as x approaches 2. And again, it doesn't have a left or a right symbol, which means I need to look at the overall limit, what's happening to the left of x equals 2 and what's happening to the right of x equals 2. So as I approach x equals 2 from the left side, right here, I'm approaching 0. As I approach 2 from the right side, I'm also approaching 0. And so my overall limit, because those are equal, is going to be 0. All right, we've got 2 more. So the limit of e to the x as x approaches infinity. So like I said earlier, I pointed out what this graph looks like already, but this is going to be super important, and I feel like this is the one that students tend to forget a lot. And so I do want to quickly talk about how you can create this graph if you don't remember what it looks like, okay? So remember, if you get stuck and you don't remember what the graph looks like, you can always just make a table, right? You can always make a table of values to help you sketch it out. So actually, I don't want to do, yeah, that's fine. X and Y. So I'm going to pick some negative values, like maybe -2, -1, and then I'm going to pick 0, 1, and 2. So the thing we have to remember is that E is a number, right? It's kind of like pi. So E is approximately 2.7, I think it's 2.718, maybe something like that. But either way, it's a little bit less than 3. All right, so when we're evaluating things with E, a lot of times we can just round it to 3 and we're good to go. All right, so if I think about plugging in -2, well, E to the -2 means I'm going to get 1 over E squared. E to the -1 is really 1 over E. E to the 0 is 1. E to the 1 is E. And then E squared. Let's see, if I said that E is about 3, then E squared would be about 9. So let's think about what this graph is going to look like then. So I know for sure I have the 0.01. I have the 0.19, so I know that this is going to go up like this. right? Well, we need to think about what these two values are going to look like, 1 over e squared and 1 over e. Well, if e is about 3, then that would be like a 1/3 and a 1/9. And as we continue plugging in negative values, our denominator is going to get bigger and bigger. So we're doing 1 divided by a super big number. And so we know then that as our x values get more and more negative, we're going to be approaching 0 on our graph. And so we're actually going to have a horizontal asymptote at 0. So this is what the graph of e to the x looks like. It's your basic exponential function, it's just that the base is e. Okay, so that's just a quick refresher of how to kind of get this if you totally forget what the graphs look like. All right, so now let's look at our actual limit for number 5 here. So we're looking at the limit as x approaches infinity, which means we want x to get bigger and bigger. And so we can see we're looking at positive infinity for our limit because those y values are getting bigger and bigger also. For number 6, we have the same graph, so I'm just going to go ahead and copy it over for us. But now we're looking at the limit as x approaches negative infinity. So as x gets more and more negative, what's happening to y? And we actually just talked about it. We said that it's going to be approaching 0. Because when we plug in these negative exponents, we're going to be doing 1 divided by some really, really, really big number, and it's going to get us closer and closer to 0. All right, if you had any questions, please make sure you wrote them down. You can put them on the Padlet so that we can talk about them when we come back to class. Thanks for watching. I will see you guys soon.